let me, first of all, let me introduce myself. As Thomas said, my name is Javier Arias, and I work as a senior software engineer in Spotify. I work in the core infrastructure part of Platform. Platform is a big organization, and Platform is handling the low-level things such as Kubernetes clusters, communications, and some higher-level things such as databases and caches. And this will enable different feature teams to develop faster and more safely and improve the developer experience for them. Preparing this talk has been super difficult because trying to summarize in 30 minutes the work of 1 year and a half and trying to give you as much information as possible and as many details as possible has been super challenging for me. So I hope this talk will be dense, but I hope it's dense in the good sense, like in the no fluffiness. I hope it to be packed with information and good data for you. And please feel free to ask any questions by the end of the talk. So the first thing I'm going to discuss is give you a bit of context of how is the engineering organization and what is the culture, so that we can understand some of the decisions we have taken. We will be discussing why we wanted to implement this product so that we can understand some of the decisions, and then how we implemented this platform and some learnings. So Spotify serves around 5 million active users every month, and it's available in over 170 countries. So the engineering organization at Spotify is quite big, and we need some principles to guide us to be productive, to be happy, and to work properly to provide value for the organization. One of those principles is working as autonomous teams, and we work in small teams, which are normally self-contained. This means all the types of roles of the different types of people you need for achieving your objectives will be inside your team. Also, this means that teams are very independent and they can decide how to work. So basically, as a team, you receive a set of objectives, a set of things you need to do, and you are free to choose how to do that. Teams are measured by how they achieve those objectives, and they are owners of their own technical decisions, and they operate their own services. This means that this poses some challenges for us as platform, because if users, so feature teams, are free to choose what technology to use, what things to use, we need to offer incentives and make things easy for them. If not, they are going to use other things. And the golden path is a set of technologies and recommendations and platforms that help users, feature teams, to be super productive, to deliver things in production following good practices, a set of very well-known technologies, and in a way that is very easy and simple. For example, we use Backstage, our own developer portal, and let's imagine we want to create a backend service. In Backstage, you will have a section where you, just by filling a form and giving some basic information about your service, basically what team is the owner, what is the name of the service, what kind of service it is, if it uses user data, if it's going to be tier 1, tier 2, if it's a critical service or not, Backstage is going to create the whole service for you in production. So in a matter of some minutes, you will have your project uploaded to GitHub. You will have a set of documentation. It will be available in Backstage, where not only you, but other teams will be able to find your project, find who is the owner, see different metrics and data about your project. You will have metrics and alarms, and you will have other things like secrets or A/B testing or canary deployments or availability. Everything will be ready for you. Your service will be in production in just a matter of 15 minutes. And with that, you will be able to start working on your features. As a result of that golden path, your service will be visible in Backstage, and you will be able to check many different things. What is the deployments, maturity levels, recommendations on security, many other different things. As part of the golden path and recommendations for backend and caching services, we use Java as the main backend development technology. We use GCP as our cloud provider, so our database, the default database is Bigtable, and we use gRPC for interprocess communication. The default recommendations for caching and are memcached, and we use our own open source client, which is Folsom, and it's available in GitHub. If you want to have a look, you can use it. How do feature services use caches at Spotify? It's important for us, at least, as a cache service producers. The majority of services use caches as a look-aside. When I say look-aside, I mean using a cache to reduce the number of queries you send to a more expensive or a slower resource, for example, a database or a upstream service. So you use the cache and you use less of that database, you use less of that upstream service. That's the most typical use case in Spotify. Also, the majority of services use memcached, which is the recommended technology with Java and Folsom. And this was around 200 or 200 and something services using this kind of technologies. So this was the most important market. There are many other services that use caches. Some of them use Redis, some of them use other programming languages, some other use the cache for different use cases, for example, for rate limiting or other things. But as a platform service, we needed to decide what is the most important use case we need to tackle, what is the one we can have more impact on. And this is it for us. Right. So what are the reasons, or why do we think creating such a platform, such a service is going to provide value to our users? So basically, we want to improve the developer experience, and feature developers and feature teams don't care about caches. I love caches, I love databases, but they don't care. They need to have data that is available, that is retrieved with very low latency, but they don't care really about caches. They are not excited. Their objectives aren't creating a cache or creating a database. Is serving their upstream services, right? In that regards, what we wanted to do is to make caches boring to our users. Boring in the sense that it's very easy to settle and they don't care about them anymore. The cache just works. It's easy to connect to it, and it's always there. It's always available, and is not something that is giving them any kind of distraction, or is not giving any surprises. That is the good sense of having a boarding cache. And also, given that we have a very significant number of customers, efficiency is also very important. Normally, when feature teams create hardware resources, they tend to use, especially in the case of caches, they tend to use expensive hardware. If they use, for example, the cloud default managed services, or if they create their own virtual machines to deploy their caches, they tend to use expensive hardware because it's huge virtual machines that hold big caches, and those caches tend to be over provisioned so that they are able to handle peak traffics plus some slack. So one cache that is peaking at some capacity is underused the rest of the day. Some cost drivers that were quite surprising to me at the beginning of the project is the interzone network traffic. We discovered that when you use a small amount of memcached instances, or any cache instance, or any hardware, any service, and you need to cross traffic between different zones. So your service is in one zone inside a region, and the database or the cache is in a different zone. You are going to pay some money for that interzone traffic. This happens, as far as I know, with GCP, and I think it's the same with AWS and probably others. If your service is busy enough and it's big enough, this will amount to a significant amount of money. So this is one of the things we wanted to tackle as well. So how do we measure success for this platform product? So really, it's the same as any other product. We want to have a very sound product, something that is good for our users, is good technically, but is good for them. Also, it's easy for them to adopt. And if it's easy for them to adopt, we hope that it will bring users to us, and they will start using us, and the project will be a success. If we are able to create a huge, a very beautiful technical solution, but users don't use it, the project will be a failure. So we want to ensure that we have both things, right? So I have a question for all of you, and this will be a poll. Given the context I've been giving, what kind of cache would you use? And for this poll, we will have two options. One will be Redis, which is a beautiful feature-packed product. Or we can have memcached, which is a very robust, fast, but not so modern, not so feature, and maybe not so cool. Which one would you prefer using? Okay, I see about 50 votes, and 75% of you have voted for Redis, and 25 voted for memcached. I hope this is not a surprise, but in our case, we decided to use memcached. Both of them are great products, and I think memcached is more old-fashioned, and probably Redis is much more sexy than it. But for us, there were two main drivers. One is memcached is blazingly fast and efficient. Not sure how efficient is Redis now, but in our case, the main driver was users were already using memcached and folsom and Java. And deciding on a technology that is good enough for the project, but that eases a lot the adoption, as it is familiar for the users, was a key for us. Right? And this brings us on what are the product principles? Why do we take these decisions, right? Let's imagine you are working in a feature team, right? And your objective is, enable podcasts or provide good recommendations for podcasts for your users, or ensure that the music your users want to listen is provided to them in under 100 milliseconds. None of those is saying use platforms memcached product. Those are not your objectives. Your objectives is try to provide value to the product itself, not use some technology or the other, right? So on one hand, you are free to choose what is your technology. Second, you already have one working cache. Your cache is working well in production, is serving your users well. Memcached is awesome and is working well for you. And then you are measured by your own objectives. So let's imagine that platform team comes and says, hey, why don't you use our cache? It's going to take 1 week for you to migrate, but we do declarative infra. I don't know, that's an enticing offering for them, right? So how can we drive adoption for the platform service? And basically the response for us, it was lowering the adoption barriers, make things easy for them. Instead of taking 1 week to migrate to our super nice cache, we wanted them to have a very easy, simple, and cheap and safe, especially safe path to migrate, right? So basically, we achieved that by using familiar APIs and technologies, by using, as I said, memcached, folsom, and by shadowing traffic. This is a feature we enable for them. So basically, we created a library that by using the same interface as folsom, their current client library, we were able to send traffic to both their old cache and to a new instance of our product. But it was done in a safe way, so that if there is any problem with our product, it won't affect the service. So it's kind of fire and forget, right? So the traffic is served from the primary, and we use our cache as secondary. We have some dashboards, and they can measure and see the different metrics and compare the old and the new cache. And they can run this experiment for different amount of time and decide if they want to shadow just a 10% of traffic or 100% of traffic, and this gives them confidence. And it's easy for them to migrate because it's the same interfaces they are already using, right? And we do something similar with dark launching features for users that don't use a cache. They can add the cache safely to their service without affecting the service in production, but they can have the cache working in production and see what are the metrics, how is the hit miss ratio, how is the memcached, how is the cache behaving, right? And with that, we make it easy and safe for them to migrate. And in some cases, we do hands-on migration. So as in this picture, we hold their hands and we help them by migrating ourselves their instances to our cache. And this is good for us because while we are a platform team, we work in their repos, we work in their code, and this helps us understanding what are the pains, what are the struggles when you try to migrate one instance to our platform. And this has been a very good source of feedback to us to understand how difficult or how easy it is to migrate to our platform. I'm running out of time, so I will be skipping some slides very quickly. We give them incentives like very good support and SLOs. So we make, again, easy and safe to migrate. How did we do it? The first thing is, and this is a poll for you, this is a question, what technology would you use to run this kind of service? Kubernetes or virtual machines? You know, historically, we have been using virtual machines so that you can run a stable virtual machine for your workload. We can use Kubernetes, but with Kubernetes we have other problems like pods coming and leaving, having small pods instead of big cache instances. Cool. Okay, so I see many of you are adventurous and decided to try Kubernetes. And some of you have gone through a most typical path with virtual machines. We decided for Kubernetes, and the reasons is because we wanted to use declarative infrastructure and because of resource efficiency. We wanted to go with commodity hardware and have many small instances. So basically, when we work with declarative infrastructure, let's imagine we want to create a cache. We are a feature team. This is our engineer. She will create a YAML file describing how the cache is, and our CI/CD will deploy to Kubernetes, and our Kubernetes operator will deploy the different Kubernetes objects, and in some minutes we will have our memcached cluster up and running, right? So this is cool, but Kubernetes poses a lot of challenges to us. When you serve a cache dataset from Kubernetes, Kubernetes moves the pods around, it creates and deletes pods, and that's a problem with memcached because data is wiped out. So what we have, also you have small pods instead of super huge cache instances, and we have commodity hardware. The network can be flooded for the server, for the node of Kubernetes. And also we have hotspots in our data because some music is more popular than other. So basically what we did to fix all of those problems, and I'm going very fast, is having many small memcached instances for every cluster. We implemented sharding so that data is partitioned between different shards, but every shard have different replicas. And the reason for that is if one replica is lost, you still have another replica where the data is. And then we do auto-scaling of the shards. If some part of your data set is very hot, this shard will scale independently of the rest. So we can scale up and down as the load goes up and down, right? So from the point of view of the client, the architecture, there is one more challenge. So we have this cluster of memcached, and we have our services running in Kubernetes as well. But how do the clients know where are the memcached pods? These pods are going to come and go, disappear, grow up, grow down. So basically what we do is we use the Kubernetes APIs, and we have our own service that is talking to Kubernetes, and it will notify every time the topology for this cluster changes, it will notify the client. So once this is done, the client will be able to establish or close connections to the nodes in the cluster, and they will start working together, right? So how this is project now? This project, as I said, is in GA. This means we are working in production with it. We are serving almost 100 of microservices and serving literally tens of millions of QPS per second at peaks. And we are serving interesting features such as playlists, everything that is playlist related, This is a platform with many microservices. It's served by us. In Spotify Wrapped 2022, in the Your Artist message features, they were using us as well. And other small tiny things, such as, for example, in the player, in the photo in the middle, when you are playing, the background color changes. So we are serving the color of that pixel from the backend, and this is cached in our services. We have many other different use cases, and many of them we are not even aware of them, because developers can just self-serve a cluster of memcached without us noticing. So we are not aware of many of the use cases we are serving already. Okay, sorry for running so quick by the end. A couple of learnings. The first one is distributed systems are bigger than I thought. And what I try to mean by that is in a big cloud service like this, or many of the platform and DevOps systems we work with, when we design and we think about the architecture, we think about services and databases and how we talk to other services, but that's not the system. The system also includes other things like the CI/CD pipeline that deploys your system, Kubernetes controlling your pods, controlling how it scales up and down. So this is part of your system as well. But there are other things like when your system is failing or struggling, you will receive an alarm. So that your alarm system, your paging system, is part of the system, right? But when you receive this alarm at 3 a.m. and you go and look at the dashboards, what is happening? What are the logs saying? How are the metrics? This is the interface, and we are part of the system because we are fixing it. We are making it available. So in the end, it's not just about the databases and the processes. It's about the whole platform around, and it's around the people. We do the system. We interact with it when we change the software. We operate it, so we are part of the system. It's not just about the processes. So we will need to apply this. One way of applying this insight is by having very good interfaces between humans and your system. For example, very good dashboards, very good alarms, a logging that is giving you real information so that you can fix your system at 3 a.m. Second learning, this is a story from the trenches. We had this outage some weeks ago. We had this system, very busy system that is sending millions of QPS to us. And for some reasons that are not relevant for this, it started getting more and more and more QPS, more requests. So it started growing up and scaling up. Our caches started growing up, scaling up with it as expected. But at some point, we saw a huge spike in the writes in our caches. And our nodes started to restart. The memcached nodes started to restart. And actually what happened is that for that service, all the cache was wiped out and it ran out of data. We made the database, we flooded the database, and after we fixed the problem by reducing the traffic, we did a postmortem, and we understood that what happened is that the client service scaled so much that we reached the default limit of memcached connections, and that produced a huge wipeout in the whole cache for that service. And Yeah, that was an unexpected bite. There were other learnings I wanted to share with you, but I went a bit slower than expected. I will hand it to Thomas.
Actually, you left us a nice little hunger here to learn more, and there's a few questions that I'd like to ask from the audience.
Okay, thank you.
2 questions from more of a detailed level, and then one general level. So, how do you manage the blast radius? Is the platform shared across all teams and features? So, what happens when you have a misbehaving client causing, for example, unexpected load on the service?
Yeah, that's a good one. So one thing I didn't explain is when you create a cache instance, what we do is we create a cluster of memcached nodes, but that cluster isn't shared between different customers. That cluster is dedicated to you. So, for example, if you have 5 shards with 3 replicas, you will have 15 servers, but those servers are working only for you. It's not a shared cluster. That's one way. For example, this is what happened in the incident I just explained. We broke the cache, but it only affected this service. The rest of the services were working well. Also, by working with Kubernetes, it gives us a huge isolation level between different services. So as far as our control plane services aren't breaking, or we have huge Kubernetes outages, basically problems are related only to users, or to specific instances.
Okay, that's great. Sorry for we still have a few minutes, but there's a couple of questions still. So how long does it generally take to convince a team with its own cache setup to move to the platform cache setup?
That's a good one. It depends a lot. Depends on how flooded with work is the team, and also what is the personality, even the personality of the individuals.
Sure.
Is affecting this. For example, we have had teams that were super reluctant. They were not that busy, but they had problems, operational problems, and they were reluctant to collaborate with us because of that. While other teams, just by hearing from us, there was an engineer who created their own instance, and by looking at our documentation, he started adding shadowing from their current memcache to their own, and they did all the process by themselves. So it varies a lot on the situation of the team, on the people, but we have noticed that when you talk to them like face to face or in a meeting, yes, and you give them confidence to migrate, it helps a lot.
Thanks for that. And there's one more thing. Oh, by the way, will you be sharing other publications or maybe podcasts or something about this work?
This is the first time this project has been talking about.
Oh, we're happy for that.
Yeah. So yeah, there is nothing related to this effort.
Okay, good to know. Okay, so one more thing very quickly. Golden paths, great for kicking off new services. How can it help feature development teams which are adding new features to an existing service? So a little bit of a generic question about platform engineering.
Yeah, so it always depends. Basically, what the golden path or what platform does is enabling certain features those teams will need, right? So let's imagine I have a small service with a database, but for some business reason, my service now is like super successful, and it's going to get like 10 times the amount of traffic it was getting like 3 months ago. By having a golden path or for a cache, you can add a cache to your service in a matter of 1 day. You can literally add this in 1 day to your service, provided your use case fits well with the needs. So this is the way golden paths help adding new features. If you are not adding any new capability to your service, it won't help. But it enables to add more capabilities to your services.
Thank you, Javier.
Hi, we're from Effico, the proud organizer of the DevOps conference.
Our goal is to uncover cutting-edge talks, emerging ideas, and DevOps trends, providing a global forum for practitioners and decision-makers to learn and grow.
We would love to also explore how we can help you excel in DevOps together. Visit us at effico.com and enjoy the inspiring talks at the DevOps conference.